Hello students, welcome to the third topic of the second chapter, that is relations and functions. So till the previous video we had learnt about how to form relations from Cartesian product, and now we are going to start learning functions. What is a function? If you recall the previous videos, the very first connectivity between two non-empty sets we had learnt about Cartesian product, right? Now let me make two non-empty sets, A and B. Right. Again, I would like to first write the Cartesian product because that is the very basis from where we have to start. A cross B is 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4. Cartesian product is nothing but the connectivity of all the elements of set A to all the elements of set B. So we have simply written all the pairs combining elements of A to elements of B. Now here we have 4 times 4, that is 16 ordered pairs, right? Now, this was the starting of the connectivity between two non-empty sets. Then afterwards, we learned how to form relation between these two. Now let us come to those examples that we had done in the previous video. R is a relation from A to B such that if I take the second one example, right, I had written B is equal to A plus 1, right? B is A plus 1. Now, what are the ordered pairs that we can form here? Take A as 1. So, 1 plus 1 will be 2. If you take A as 1, the value of B comes out to be 1 plus 1, 2. If you take A as 2, 2 plus 1, it is 3. Now, A as 3. So, it is 3 plus 1, 4. Now, the last value of possibility of A is 4. But if we put 4 here, what do we get? 4 plus 1, 5. See, do we have 5 here? No, right? So we are not supposed to write this ordered pair at this place. So this we cannot write because I told you earlier that whatever has to be written here in the ordered pairs or in relations or in functions, it has to be a subset of this. When we don't have 5 in the second set, 5 does not exist in either of these ordered pairs of the Cartesian product. That means we cannot write this pair here. 4, 5 does not exist because 5 is not an element of the second set. So even though 4 is there, right, we have an element here, but since we don't have the image of 4 in the second set, so we cannot write 4, 5. Right? And we can see that all of these 3 ordered pairs are already here in 1, 2, 2, 3, 3, 4. These 3 ordered pairs are here in A cross B. Now again, R is a subset of A cross B. So till here we had learned in the last video also. Now how do we go to the concept of functions from here? R is a relation or you can say it's the subset of A cross B. Now what is a function? What is a function? Now listen carefully because we have restrictions here. Function. A relation in which, that means, see, when we define something, very precisely try to understand this thing. We have already defined that the function first has to be a relation. Like if we talk about rectangle, it has to be a parallelogram first. So it is a special kind of parallelogram. Rectangle is a special kind of parallelogram. Similarly, for a connection to be a function, it has to be a relation first, right? So a relation in which there are two criteria that a relation should satisfy to become a function, right? A relation in which all the elements, I'm telling you in a very simple manner, not mathematical one, so that you, once you remember how a function is formed, you remember its properties. All the elements of first set are being used. And the second property is every element of the first set has a unique image in second set, in the second set, right? Now, how do we check this? Now, first of all, you have to check whether this given relation that we have taken as an example, whether this is a function or not. So now we go by 2-point test. The first point is all the elements of first set are being used. Now the first set here has 4 elements. That means you should have 4 ordered pairs where all these 4 elements are being used. Do we have here? See, 1, 2, 2, 3, 3, 4. 4 is not getting used here. Now you can say 4 is here, but since we do not have the image of 4 in the second set, we cannot use 4 here. We have a restriction. We don't have image. There is no such element we can link with 4 to this here, which is satisfying this particular relation. So we haven't used 4. That means, according to the first criteria, this relation is not a function. So even if the second one holds true, we can say this is not a function, right? Still, we are going to check. How do we check the second property? Every element of the first set has a unique image in the second set, right? Every element of the first set, like 1 has an image 2, 2 has image 3, 3 has an image 4, right? We can say that like 3 cannot have 2 different images, 4 and 2. One element of the first set cannot be linked to 2 different values in the second set, right? Because here, let me take another description. A function basically is a machine, right? A function is a machine. Let us consider it this way. Sorry for my poor drawing. Still, I would like to make it better. It is a machine, right? Now you know what is a machine. A machine is a device in which you give some input. Machine works some way. So we have to give the input, whatever we want, whatever input we are going to give it to the machine, we require a particular output from it. So we prepare machines for that function. So here the function is like, if I say, let's say, take some other example. Whatever number I am putting inside, like x and f of x function, we also denote this as y. Now, x is the input and fx is the output. And how do we define that function? Fx is the output. Now, if I write fx is equal to x plus 2, right? Whatever x we choose, it can be a real number, it can be a fraction. But we have to define our set here for the domain. What are the values we are choosing for x? Let's say we are just using whole numbers. We are starting with 0. So if I put 0, I will be getting 2. If I put 1 here into this machine, what output will I get? 1 plus 2, 3. This is the function that machine is performing right now. It is adding 2 to the given value. This is what we call a machine is meant for. Whatever programming we do to the machine, it gives the output in the prescribed manner. So input is 1, output is 3. Input is 2, output is 4. Now see, Do we call a machine doing functionally well? If we put 2 ones, we are getting 4. After half an hour, I am putting 2 here and I am getting 8. That means we can say that the machine is not doing functionally well. We have to get it rectified. And that means when we are putting the same input and the machine is providing different outputs at different timings, that is not called a function. Right? So just consider this the basic value. For a single input, we cannot have 2 different outputs from a function. So every element should have a unique image. Now this can happen. See, I'm giving you another example, right? Because function is a very complicated thing. Children generally get confused between functions. So make yourself theoretically very strong so that the questions are not a problem because you have your concepts well imposed in your mind. Now fx is what? X squared. Right? Now I have programmed my machine to make the square of the function or whatever the number I'm giving into it, just make the square of it. So now my set of input has been changed from set of whole numbers to set of integers, right? Set of integers. Now what happens if I put f of 0, I get 0. F of 1 is 1. What is f of minus 1? It is also 1, right? So see, what is the difference here? That's why I have taken these 2 examples. So just to illustrate, when the input is same, we cannot have different outputs. But there are cases, there are machines for which, like if I am putting -1, the image is same for both. 2 different values of x can result into the same image. But still, this is a function, right? What the case is, in this case, it is not a function. That when the same input, we are getting different outputs. That is not a function. But for different inputs, we can have the same output. That is defined in case of a function. I hope things are clear. Just try to imagine these 2 things. Same input, different outputs, it's not a function. Different inputs, same input, we can call it a function. It is called a many-one function. Many-one means -1 and 1 are related to the same image. Many-one is a kind of function. We will deal with this later when we are doing types of functions. Many-one is a function, but one-many cannot be a function at all, right? That means 1x cannot have different values of y. So these things you have to remember before doing the complicated questions. Just go by the practice of those questions in which you have to check whether a relation is a function or not, right? So now I have told you how to check. Like this was not a function. Okay, let's come back to this thing only. Let me try making this function, right? Okay. What if I add, I'm not going to erase all these things because I will be dealing with the whole dot question again. If I write 5 here now, right? I'm just making it 5. Now see, what was the restriction earlier? We could not write the ordered pair for 4. Why? Because there was no image according to this relation. I'm still, since you don't get confused, I'm writing this now in a proper form. Now I have 1, 5, 2, 5. These are the left out numbers after adding 5 to it. See, now there are 20 ordered pairs. I have completed the Cartesian product, right? Now we have 20 ordered pairs in this because here we have 4 elements, here we have 5. So 20 ordered pairs are there. Relation being the same, right? Relation being the same, R is a relation from A to B such that B is A plus 1. Now see what I can do here is, what happens? Now, earlier we did not use 4. Now see, if I use 4 at the place of A, 4 plus 1, 5. B becomes 5 and 5 is now available in this set. So I can write this as 4, 5. Right? So earlier it was not a function. Now check again. The first criteria says all the elements of the first set are being used. Now see, the first set has 4 elements. Enough. So see, 1. This way you will be getting 1 marker questions, even 2 marker to find something. So just go for the elements of A. You will be getting A like this. They will be giving in sets, and just see, using all those elements, do we have ordered pairs which are using all these elements at the first place? Like 1, 2, 3, 4. Check 1, 2, 3, 4. Yes. First property is justified. All the elements are getting used here, right? The second thing is, every element of the first set has a unique image. Every element of the first set, right? That means, now how do we check in fast? See, don't go by this way. Like the basic thing is to check whether the first element is occurring twice. What did I tell you here? 2, 4, 2, 8. What happens here? 2 is getting used twice in ordered pairs. That means 2 is having 2 different values as the images, right? Now see here. Is there any ordered pair in which any first number is getting repeated? 1, 2, 3, 4. We have 4 elements in the first set, and we have exactly 4 ordered pairs in which all the first elements are different. That means no number is getting used twice. That means every element, 1 has a unique image, 2 has a unique image, 3, 4. No number is being repeated at the first place, having 2 different values at the second place. That means this property is also justified. So this is properly called a relation being converted into function. Relation which is exactly a function. Right? So I hope the things are now clear. So always check for 2 things. First of all, when you are going fast, the concept is clear, but you have to same time, you have got only 1 marker. Check for the availability of all these numbers at the first place. Right? First property check. Now, for the second property, theoretically, you take time to absorb things. But mechanically, if you have to check, just check. According to the second property, you don't have any first element being repeated in the ordered pairs. That's it. If it is both the cases are justified, this is a function. Right? So I hope functions are very much clear now. Now, what is the next topic? I would like, since this is a function, I'm erasing things from here to explain you what is the domain of a function. Domain of a function, right? You must have seen there is a difference between the domain of a relation and domain of a function. What is that? In case of relations, like I had just converted this question into functions, so that got erased. Earlier 4 was not there. Sorry, 4 was there, but 5 was not there. 4 was there, but we did not use 4 because 5 was not there. So in case of relation, what was the domain? In case of relation, it was only the set of first elements that were occurring in the ordered pairs. Now, in case of relation, whether we had used 4 or not did not matter. So 4 was not used, still it was relation. So we only wrote 1, 2, 3 in the form of a set. That was the domain. But in case of domain of a function, what is the difference? The thing remains same. This shows, like in a relation, the set of first elements. Here also, the definition remains same, but in the nutshell, we can say that if all the elements of the first set have to be used, so we can simply say the whole first set is the domain of the function, isn't it? Domain of a function. So the first set of first elements. Definition is still same that we had learned in relations, but in this case, since the thing has been specified as we have to take the whole set as a first pair, first element of the ordered pair, so we can call set of first elements or The first set is the domain of the function, right? The whole first set. Now that can be finite, that can be infinite. We will see later when we do some questions. The whole first set is called the domain. The domain is set A. So there is a difference between domain of a relation and domain of a function. In domain of relation, we just have to choose those elements which have been used. There might be few which may be used, may not be used. But in case of functions, since we have to use all the elements, so the whole set becomes the domain, right? Then again comes another definition, which is called codomain. Codomain, right? Codomain is the second set. The second set from which values of B have been taken. Values of B have been taken. B or the second values have been taken. Now here I am talking about codomain. That is the whole set B, the second set. Because we choose, if we take this as X, this as Y, the X set is the domain and set Y is codomain. Second set is the codomain, right? Here we have B. So domain of a function and codomain of a function. Now, what is the range? Range of a function. That is exactly the same as in the case of the relations also. What is the range of a function? Range of a function is the values of the second elements in the ordered pairs. Okay, ordered pair. Now we will do this thing. Now what is the range? Here it was the whole set. Codomain is the whole set we have used to find the values of B. Now see in this particular question also. Have we used all the values of B? These are the ordered pairs of the function. 1, 2, 2, 3, 3, 4, 4, 5. This is exactly a function. So what do we see here? For the second elements, we have chosen 2, 3, 4, 5. 2, 3, 4, 5. Right? So the values of Y or values of the second element actually form the set of range. That is same as in the case of relation. So here, the only thing is, 1 is not getting used here at any position on the second place. 1 is not getting used here. So range is something which may or may not equal to the set of codomain. There might be few values which are not being used as the second element or as the images of the first elements. So range is a subset of codomain. Range is a subset. It may be proper, it may be improper of codomain. Proper subset of codomain. Here it is a proper subset because 1 we have left out. We don't have 1 here. It is a proper subset of B, if not improper. Had 1 been here, this would have been the whole set. In that case, it is the improper subset because we have chosen the whole set. So the codomain is the whole set B and the range is only these 4 values which are being used at the second place. Right? So this was all about the functions. How do we define a function? How do we check whether a relation is a function or not? What are the different criteria? And domain and range of a function. So I hope you like this video. Go through it twice to absorb the meaning of this concept. This is very important concept you will be dealing with in later classes. So I hope you like the video. And if you have any query or you want to join my classes, do contact Urban Pro. And thank you for watching this video. Thank you.